what properties has this generating function theta, the theta function of the quadratic lattice L? By the definition, the theta function is periodic. This is evident because we define this function as a function in Q. But this is very, very important. Then this generating function has a hidden symmetry. More exactly, this function satisfies a functional equation of the following type. We can calculate the theta function at 1 over tau. And we can calculate this series. One can prove that this is equal to tau over e to the power n over 2. I remind you that n is the rank. N is the rank of the quadratic lattice L. So, and the function at -1 over tau is equal to tau over e to the power n over 2 times determinant of the lattice L to the power -1/2 times the same function, tau, but for the dual lattice L. The dual lattice, what is it? L star, L dual, is by definition the lattice of all element u in the rational quadratic space generated by the lattice L, such that for any v in L, the scalar product of u and v is integral. Our lattice is integral, so L dual is a larger lattice. L is integral. So you see, in our equation, we can compare theta function of the lattice L at the point -1 over tau and theta function of the dual lattice at the point tau. What is this transformation? Let's consider once more the complex upper half plane. This is 0. This is on the real x. If we go to infinity, we go to the point I infinity. And -1 over tau interchange these 2 points. I infinity and 0. This is transformation from tau to -1 over 2. So you see, when we are working with our generating function at infinity, we get another generating function at 0. This type of effect we have in physics, more exactly in some mirror symmetry consideration, when we compare two different forces, strong and weak forces, for example. So this functional equation, which is really some hidden symmetry of our theta function, has very nice form if the lattice L is unimodular. Let's assume that L dual is equal to L. This is equivalent to the fact that determinant of L is equal to 1. We have such positive definite even integral lattice, but only if the rank of our lattice, n is the rank of L, is equal to 0 modulo 8. So let's assume that we have a unimodular lattice. Then the functional equation has the following very nice form. Theta function at -1/2 is equal to the power n/2 times the theta function of L at 2. I add the evident property, then our function is periodic. And we get a function which is usually called modular form of weight k with respect to special linear group SL2Z. So the question, which you can put immediately, why we have the group SL2Z here, which we usually call the modular group. The explanation is very simple. So the group SL2Z, or more generally SL2R, that is a group of real, we add some notation here. This is a group of matrices A, B, C, D with real elements of determinant 1. This group acts on the upper half plane. By fractional linear transformation. And the integral special linear group is generated by two elements, T and S, where T is the so-called translation lattice, and T transform tau in tau plus 1, and S, the involution, sends tau at -1/tau. So now if we analyze more carefully the functional equations of the theta function, we see then the first equation is related to the matrix S, and the second to the matrix T. If we combine these two equations with respect to S and with respect to T, we can get all translation with respect to the group SL to Z. So SL to Z, this is very important for our consideration, discrete group acting on the upper half plane. A little bit later, I give you the formal definition or the correct definition of modular form of weight K on the upper half plane. But now I would like to analyze our arithmetic problem once more. What's the problem we put? We have even integral positive definite quadratic lattice L, and we try to analyze this quantity. We would like to analyze the number of representation of an integer to n by vectors in this lattice. We define the generating function of this lattice, but now I would like to consider a more general function, a function which is more general than this generating function, the so-called partition function.